So this is the DSF Final project for the robot arm. This breadboard right here contains the FSM and any additional supporting circuitry. So for this demonstration, I'll only be using one stepper motor, and we'll be working with this PCB right here, powered at 7.5 volts. These three LEDs down the left-hand side of the breadboard actually show the one hot encoding. So this LED indicates the recording state, this LED indicates a moving state, and this LED indicates an idling state. Now you're not going to see the idling state used here. That was implemented because of design day. It was to help coordinate three motors. There's actually a separate coordinating circuit that works with more of a parallel programming problem and not part of the individual project. These two LEDs over here are actually address indicators. In a sense, the robot arm's overall layout is like a mini microprocessor where we will cycle through memory addresses, and these two LEDs will indicate which address we're on. Note that the output of the circuit is actually a gated clock with logic, it's actually an enabled clock, and we would like to be able to change how fast those clock cycles are, as that will change how fast the motor is driven, hence this potentiometer right here. All it is, it's a 40K to 240K resistor on R2 of a 555 clock. So let's go ahead and get started. We'll disengage the motor on the PCB and just give it a few positions. Sorry. So we're going to go ahead and set this as the origin, and then we'll spin it by hand to a few other positions. Let's see if I can lay my phone down and get a shot here. So we'll record that as one position. Record this as another. Go back to what we said the origin was as the third, and call this the fourth position. And so as you can see, the one hot encoding indicates we're actually in the playback state. Motor is not moving because it's not engaged, but the moment I engage it, the output logic should drive it back to the first position. So it's engaged, output logic is driving it towards the first position we recorded. And we transition into the second position, which will be over here. And we go back to that. Go back to the last position up here. And then we'll cycle back to the first, and so on. So if you can look at what's going on the breadboard, you see that we, as indicated, we are staying in the moving state. And you can see that our address indicator LEDs are actually cycling through the very addresses. So right now, as we're moving to the first position, we are moving towards address 0, or the position stored in address 0. Once we get there, we cycle into address 1, cycle into 2, cycle into 3, and we'll play back until, as the problem description prescribes, someone hits the reset button. So we stop, and as you can see, the FSM is back in the recording state.